Number 34. The data given in the table below shows some of the results of a study comparing the height of a certain breed of dog based upon its mass. So mass is listed here and height is listed here. Write the linear regression equation. So that is one goal that we have to do. Write the linear regression equation for these data where x is the mass and y is the height. Oops, sorry. X is the mass and y is the height. Round all values to the nearest 10. Okay, so when we're writing a linear regression equation, what we're going to want to do is type all of this data into data and spreadsheets. I already did that here. There it is. Okay, so go ahead and pause the video and get mass in one column, height in the other, and then we're going to calculate the linear regression equation. So pause the video and then meet back here. Hello and welcome back. Okay, so we're going to go menu, 4 for statistics, 1 for stat calculations, 3 for linear regression. You want mx plus b. Your x list is what you put in the x column, which was mass. Your y list is what you put in the y column, which is height. And then you're going to want your output to come out in column C. Hit OK, hit OK. And here we go. M, or the slope, is 1.917. The problem told us that they want us to round all values to the nearest tenth. So we're going to go ahead and write down M equals 1.9. And then the B part of the y equals mx plus b is going to be 29.79, which rounds to 29.8. We're going to go ahead and substitute them into the equation of a line, and we would get y equals 1.9x plus 29.8. Okay, that is our linear regression equation. Then we're going to want to state the value of the correlation coefficient to the nearest tenth and explain. So we need to state R, and then we need to explain what it indicates. So R can be found in our linear regression equation calculation. We don't want R squared, we do want R. R is 0.33709, and we want to round that to the nearest tenth, so it would just be 0.3. So we are going to want to state that R is equal to 0.337. Then we're going to show our rounding. R is now approximately 0.3 after we rounded. We have stated R. Now we need to explain, and it was in the nearest tenth. Now we need to explain what it indicates. So whenever you're explaining what the correlation coefficient indicates, you need to describe the strength and direction of the relationship. So a correlation coefficient, here's my explanation, of 0.3 means that here's where you mention the x variable, so the mass, and now you mention the y variable, height of a dog, and here's where you mention the strength and direction of the correlation. So since R is positive, we would say that it has a positive linear correlation. And now we mentioned the strength of the relationship. R is much closer to 0 than it is to 1. 1 is an excellent or a very strong positive correlation between the two variables. 0 is a very weak correlation between the two variables. 0.3 would just be considered a weak. So we've mentioned the strength and the direction of the linear correlation between the two variables, and we are now done with our explanation.